The project showcases a GitHub Actions CI pipeline utilizing Vitest for unit tests and Playwright for E2E tests, achieving a runtime reduction through effective caching. The motivation is to automate testing for production deployments, moving from manual local tests to an efficient CI/CD workflow using GitHub's infrastructure. Key takeaways highlight the benefits of using GitHub-hosted runners, including significant time savings through caching and best practices for dependency management. Installation is as simple as running a pnpm install command to set up the necessary frameworks and dependencies. To run tests, simply push changes to a branch and create a pull request to trigger the CI pipeline automatically. Technologies utilized include Next.js, TypeScript, Node.js, and various testing tools, which form the backbone of the project. Core concepts covered include the definition of a GitHub runner and the implications of public versus private repository hosting. A GitHub runner serves as the engine that executes jobs defined in GitHub Actions workflows, critical for automation. Cost and availability for runners differ. Public repositories have unlimited minutes, while private repositories have a limited monthly usage. Public repositories benefit from unlimited CI minutes using both GitHub-hosted and self-hosted runners, ideal for open-source projects. Private repositories face a quota of 2,000 minutes per month, with GitHub-hosted runners, best for low-maintenance tasks. The design section outlines project constraints, evaluated hosting options, and the caching strategies implemented for efficiency. Constraints included the need for minimal costs and hosting a private repository for the micro SaaS platform. 3 evaluated runner hosting options include GitHub-hosted and self-hosted runners, each with specific advantages and trade-offs. The chosen design emphasizes starting with GitHub-hosted runners for simplicity, planning to add self-hosted options as needs grow. The caching strategy maximizes efficiency by utilizing GitHub's free cache storage to minimize test run times significantly. The final setup confirms the use of GitHub-hosted runners along with pnpm and Playwright, achieving significant time improvements during tests. The code structure section reviews the workflows before and after caching, detailing the performance impact of these configurations. This section presents the GitHub Actions workflow configuration for a test setup without caching, outlining the basic steps involved. The updated workflow configuration with caching illustrates the optimized steps that enhance performance and reduce runtimes. The caching workflow implementation includes steps for managing Playwright browsers, improving efficiency by leveraging cached assets. A simple unit test example demonstrates the use of Vitest for testing a basic condition in the application. The end-to-end test illustrates how Playwright is used to check that the application's homepage displays the expected heading. After pushing to the dev branch, the demo outlines the pull request creation process, enabling CI testing in GitHub. Steps to create a pull request are illustrated, highlighting interactions necessary to trigger the CI workflow. Subsequent steps focus on merging the pull request, which acts as a key moment in the CI/CD process. This section discusses the results of running the workflow without caching, pointing out the time inefficiencies observed. The workflow with caching shows significant time improvements, demonstrating how caching directly impacts CI efficiency. This section provides an overview of the optimized workflow when caching is effectively utilized, resulting in faster test runs. A list of references provides additional resources for understanding GitHub Actions and their integrations with CI/CD workflows.